Before he's ready, I'd like to introduce myself. My name is Hans-Joachim Graf. As you see on my pronunciation, I'm from Germany. And to explain this title, Best Practice of Rubber Chemist in Material Development, we heard a lot about vacuum at the moment with the first speech, and now I'm talking a little bit about vacuum, what we normally call brain. Yes. Okay. So it's a little bit of my experience, which I have already in my 40 plus years in industry or something like that. And that's a little bit the question when we are in material development specifically, then we actually are in charge of the majority of all the costs in production. Yes, if you see mixing, for example, you have material costs 90% on total. In extrusion, you have around 70% cost on total. That means 30% is left for a fixed and variable cost for overhead costs and things like that. Just to imagine the importance of compound and good compounding, which some of the rubber producers are taking care of. So and then we have, of course, educational system. And with that, we can decide whether this is more very theoretical and we have a gap to practice, or we do a little bit of both. Yes, so you have a French system, IFOCA, where people have full study, then they do rubber technology. And so there is also a practical experience in hand with that. And you know, for example, German education system is always both sides. That's why we have not enough chemists in Germany, actually, because it's heavy load on your personnel. So then the question is where we want to go. And at the moment, yes, we have a large generation exchange. And that means we actually see a shortage specifically in Europe. I'm not sure in this country here if that's similar or not, or in this Asian area. And of course we we cannot say young people are experienced. That is a conflict. So every human resources manager, of course, try to hire experienced, very young people. Yes, so it's a little bit of a joke. And not surprisingly or surprisingly, I'm not sure, actually we have no degree in compounding. Yes, we have material science and we have all the polymer science or engineering science, but actually compounding as itself, we have no degree for that. So we offer courses and training seminars, but not more. And the question is this enough, yes or no? And then our management often presses at that we have a magic solution, like a witch doctor, something like that. And I think that is an unfair pressure, specifically to people who are having not enough experience to let me say, there's a large load actually. So what we need actually, you see here a type of chart I copied from a presentation. And what's really important is the technical expertise and cost and productivity improvement. And we have very little actually with really new compound product development. That is seldom. Mostly we work in optimization. And this means we have a lack of understanding how much science actually is involved if you go in optimization iteration. And then we have all our rules. Everybody says he will be world class in knowledge, and obviously to achieve that takes a long training and a good team to get that. And then, yes, for our managers important, we can convert that into dollars. So then we have the word innovation. And the question is, actually we're talking about cost and cost cutting. We're also talking about troubleshooting. Actually, if we are Six Sigma, we should not have any trouble anymore, yes? This is a term which gives us a conflict in the wording. So we have a failure prevention, actually, and we have adjustments for our machines in productions, and probably adjustments to specs if we have material which has a trend and runs slowly out of spec. So with that in mind, then we said in the past that we think about a focus on innovation and about our future in rubber industry. So if we are really saying we want to compete at any price, yes, how is our business then going? Are we not lost if we are only competing on price? So then we say future business and cost cutting and quality improvement has something to do with technique, if not with science. So that is a real message out of this. So then we have an environment in our companies, yeah, where innovation should be the norm. I always making a little bit, not a joke, actually it's a reality, that if you see office space for people are taking care of the majority of our cost, yes, that they have the lowest or the worst offices and the worst office furniture compared to other departments. Okay, so we have a focus then, and that's intellectual property. We are not patenting our ideas so much in this industry except Michelin or Bridgestone. So why they do that this way, I don't know. Our intellectual property is mostly hidden, but we have to take care seriously that we have that. Then we have so-called best practices in our plans, and it is hard to implement best practices in our sister plant, for example, or in another company. But that is a challenge to do so. Then we have probably even in larger companies centers of expertise, and the question is how they cooperate and how they work together to gain the best ideas. So and then we have to take care that we training the people, because employees are building the company. So I'm not sure how close that is to what we think about employees. Yes, we have World War II in Europe, specifically in Germany. All property were damaged. There was nothing, for example, from BASF anymore. And then 5 years later, the old daughter of IG Farben was larger than the mother. That was only because all the people came together and rebuilt the company. So a company is not machines, a company is people. And we should appreciate that. And of course we have an organization. We always see in our organization chart a pyramid, so that is top down. Actually, I like to reverse that to bottom up. That means our management should help us to make our job. That's the message of that. And then typically for rubber, you have to have a lot of expertise to serve the production line. This means you have a logistic, you have engineering, you have chemistry, you have physics. And so to serve this line, it is mandatory that you work in teams. Yes, and in teams we know how a team works. That is when we look at soccer specifically, or those sports. Yes, and everybody knows team and that only a team can win, but in industry by sudden we forget that sometimes and we do not cooperating effectively as a team. And here see again our business mixing, for example, physics, engineering, chemistry. So actually if I have a problem in my mixing line, I should always 3 people there. And for this, when I worked in my 2 of my groups in my past business life, I had really the luxury always to have a chemist and an engineer together in my group. So that was very powerful in analyzing and problem solving. Yes, and specifically in forming, I need a rheology knowledge. And you see chemistry, engineering, chemistry, physics, engineering, and you probably know that if you work in this industry. So then you see here dependencies, material variation, having a large influence on my mixing process and quality, achievement in compound properties. You see a word specification, average specification independent actually of raw material variation. That's what I want to have. And then here I want to have stability, production likes rhythm and stability, of course. And then cost advantage would be if I'm going in a process window just in the upper edge to get the maximum out, which gives me a challenge to keep that in steady state. So and then of course the part is a customer expectation, and he wants also the maximum, but pays nothing for that. So, lack of teams dedicated to innovation. I see a lot of my colleagues spending their life in laboratory and in a surrounding area and not enough on the compound floor. And I say that I can only learn my lessons or what I have to know if I'm seeing that by myself with my eyes, touching that with my hands, because we need to notice that we humans are eye animals. Yeah, we are thinking in pictures, and we have our hands for feeling and touching, and that gives us the way to absorb and then to analyze. Yes, so as a human we need to see and feel, and I can only do that by myself. Nobody else can do that for me. So and then the word benchmark. It is a little bit challenging, yes, to benchmark yourself with somebody else. You need really to come into contact, somehow be a friend, but you have also presentations, for example, you have discussion forums and things like that. And then my question is, what is the difference? What can I learn? Yes. And actually where he comes from, if I'm benching myself. What is the base of his ideas? So, in other words, we need to listen. Yes. So not to talk, but to use our ears. And then the question is, we are dealing a lot with beliefs. Yes, can it be proven scientifically? That's my message here. Everything what you hear and what you read, and you get a chance to prove that scientifically by experimentation and analysis of the result. So if you follow the best practice, ensure that it is designated, justified, and supported by data, not by anybody's word you may hear. Yes, I'm stretching the term beliefs again, because we are engineers, we are chemists, we want to know and not follow a rumor or whatever. And you cannot depend on that. So if I'm discussing, for example, a problem with you, yeah, I want to see first the facts of your experiments, that you share that with me. Then I'm going in my office and making my conclusion. So now you have your conclusion, I have my conclusion. Now we can have a discussion, yeah, face to face, really, and then we see which conclusion or argument will win in the discussion. So it is a little bit forceful, yes, but also straightforward, and if we are respecting each other and listen to each other, then the better argument will win, yes, or even we may split out and say we need more experimentation to support our analysis. I think that is one of my key messages as well. And even if we have a problem, why we not talking an independent body to confirm or to disconfirm what we think? It's a little bit challenging for a human, yes, to get in such a process, because we like to be happy, and here the outcome can be a problem for us. But we should have no fear, yes, because we learned. Kids have no fear. As adults, we lose that a little bit, or we create the fear in us. So we should act more like small kids. They are much, much better in learning than we are when we are becoming adult. So then, do everything to increase your knowledge. You see here a small machine, which I created in my past when I was at a machine, actually to learn something about rubbers. For the very first machine as a laboratory machine designed, and you see here also a certain control unit. Actually, there's a computer unit that I could manage an experimental design here with a specific software, and then this both machine control and this could communicate on it was to make the easier output. And I used then this instrument actually to measure rheology properties of a compound in a type of semi-scale environment. So that helped me to learn about flow, and it helped me to learn about rheological behavior of rubber. Okay, same thing as with an extruder. Actually, this is a machine which measures by motor power conversion rheology properties, and we can use all those to increase our knowledge about rheology, for example. Okay, and then, you can identify people which you can call the best. And of course, again, learning. Yes, we say that we should do that all our life, and I think that is a pretty true statement. And then we have a big problem in industry generally, I believe. Yes, and that is we are not taking enough time to report, because we are driven just to the next problem. Yes. And we had in one of my group, there was an engineer. Yes, he was a brilliant guy, very high, very intelligent. And actually, we closed the door of his office and said, "You are not coming out before your report is finished." Yes, because that you have to have written knowledge of your company somewhere. Yes, we are humans, we forgetting. Yes, we having a focus on other things, and that drives us to forget a lot of things. And specifically, if you do statistic experimental design and combined with your experimentation, that is a big problem. And I feel that by myself, how fast that gets lost. And if you do such an experiment, you see, I link that to a type of thesis which you have written probably when you get your master, yeah, or your bachelor degree. And actually, every project for me is like a thesis. Yeah, so I should have a similar report and a similar report structure as I learned in university. And writing helps to clarify my mind. That's actually the sense, yes, because I have now the possibility to see what I have thought through. Yes, so I'm becoming again an eye animal, and that is much more powerful also for my memory. On here you have an example of a structure of a report. Let me stress 2 points. Executive summary is actually the outcome of the experiment, and that answers the question, should your boss do something or not? Yeah, so you give him a message, okay, you need to do something or you don't need to do something, so you can play around with your computer or telephone or whatever. And the short summary is actually a shortage of the discussion that is actually for myself. Here I clarify my mind with a few words to, let me say, get the extract of the discussion. So then you have documentation and storage. Yeah, better you, I'm an old-fashioned still, yes. I say paper survived 4,500 years so far, and the computer, I don't know, or hard drive or CD or whatever. And then you should communicate, actually. So materials group has the information, process engineer should have the information, and probably the plant manager should be involved, who is supervising the operation. And today with computer technology, no problem anymore to inform. In the past we produced much more paper. So and then what I learned sometimes in my activity as a consultant or so, that when people have made their conclusion, they have a little bit a lack of confidence. This is the conclusion. Because when you now face the manager and he's asking you, and should I spend now or invest money for this or that? Yes, you have to look in his eyes, and your eyes should be straight. Yes? It's like the wolves looking each other. And the manager has no, not the scientific background as you have, or the education that you have. He depends on emotion, what he sees now in your eyes when you look at him. That is always the same thing in all the world. Yes, so you have your confirmation experiment, and you have done your search, and maybe have asked some more experts. Then you should be confident. So you go in a corner of the wolf, you look at him and say, this we need to do, period. Okay, and what is a little bit lacking, and only one company joined, where we actually celebrate a good result. Yes, because we are humans, yes, we like to enjoy something. That gives us a really motivation forward, like the kids. Yes, you say, oh, you did that good, yes, and then you give the kid a sweetie or whatever, yes, so that is celebration. So enjoy your success and celebrate the success. So make a party in the evening or whatever, yes? So, and then you have a lot of people in the world. Yes, you ask them a question and they have a very, very quick answer to that. Yes, I'm always very cautious with that. Yes. So rush conclusions or rush answers are for me very, very critical. And the other thing I like to mention is our brain guides us sometimes to a solution, makes us happy. Yeah, that is an automatic process. So you need to be cautious with your own conclusions. That is a real challenge. I know that. I get trained by a very tough boss at the very beginning of my career. He was very harsh, and I learned that is really work. Yes, that is not easy to do. Okay. So what we said then later in another position, yes, if I have found a solution, for example in plant, then I should turn on, turn off, and on again. Yeah, so if I'm really interacting with the process in this manner, then I got it. Yes, there is no doubt anymore. So and then we have workload and stress. Yes, it's in Europe a big issue at the moment. I'm not sure in your environment if that's the same discussion. Maybe for me, I divide workload from stress. Yes, stress is different from workload. And let's make a statement here. Sometimes we are shy to ask for help. Yes, even I'm old and you may see me as a whatever good father of compounding or whatever, or rubber technology, don't do that. But if I don't know anything, okay, I go to somebody who might know. Yes, and ask him the question, how you see that and whatever. That is not losing my face or something like that. It's just like a kid comes to you, yes, and says, why mommy is this? Yeah, and you answer until you get crazy. So we should be the same. So, and then we have a little bit the attitudes. I saw that in a lot of places, not invented here, yes, as an offense to the big engineer, yes, but I need to accept that we are all different, yes, and somebody may have a brilliant idea. And then I enjoy that he has an idea, and I turn that into my advantage in my environment by maybe small adjustment or larger adjustment, no big problem. This is a big challenge for specifically in a plant operation in larger companies. So, key messages of what I said, cross-functional teams. I have to learn by interaction with the process. I need to feel personally responsible as a compounder specifically because company depends somehow on me. Remember, yes, that we have the majority, we control the majority of our costs with raw material and compounds. Look out for best practices. Also, we should have always a good relationship to university staff and university environment. And then accept that there are brilliant people out with very nice ideas. And for this, thank you very much.